I think this is recording. I'm trying a new camera. Yeah, I mean it's an old camera, but it's a new camera. It's really this is infrared kind of thing. Doesn't appear to be turned on now, but it's a sort of interesting. Yes, it does it when it's not supposed to do it, and the little infrared lights don't turn on at the right time either. So anyway, it does give you some interesting distortions. Just look at some of my plants. Doing well. Plants. Glass. Maybe lots of plants. Hopefully, plants up there. Yeah. Anyway, we'll walk over here maybe. Ooh, gotta water that stuff again. I gotta plant that stuff now, but I'll do it tomorrow. Sorry, just looking in there. The two slit experiment. Yeah, so I'll play some video. So I'll wait till later to do that. Add that on here. Just really pleasant evening here. Very nice. See what the pond looks like in different lighting. But the interesting thing of this camera, what it does do, which is really interesting, is it really makes a distinction between what is actually dark and what is just a dark color. Like we see things as being dark sometimes just because the color is dark. You know what I mean? So this takes away that effect, and you end up seeing things for what light is being produced rather than what color they are. What energy comes off of them, photons kind of thing. So you get different kinds of shadowing and shading, which is, I think, somewhat interesting. So anyway, I'm going to read comments, and Hospital Day keeps, he just makes idiotic statements. I'm not making any claims. This video was just covered with scientists claim, they claim, this experiment claims, everything claims. Those are claims. You're claiming there's some sort of authority. You're claiming there's some sort of legitimacy to those statements. And my question is not that complicated. You keep saying AIM doesn't have anything to do with it is stupid, because you have to deal with it because it creates a paradox. The idea that photons can tell how they were injected into the world, that they somehow carry that information, just the simple information of me pointing a gun and me not closing my eyes and just randomly shooting, that somehow makes a difference. And clearly what I'm arguing is no, that's ludicrous, that's idiotic. If we design the experiment so we know the gun only shoots through the A slit, and then we have the position of the gun where we know the photon can only go through the B slit, and we combine those results and with the same number of photons going through, we should get the same result as we get from random. And it creates a logical paradox to think that somehow photons can tell the difference. They can't. And what's really creating the phenomenon in the experiment is the matter the photons are being forced to interact with in the randomized experiment, because now we create a fake focus, and it's that focus that creates the improbability. So what I'm going to argue, and so I'll say it now and then I'll argue it through the video, is that they have the source of the probability wave function wrong. The source isn't photons, it's electrons. Electrons create the phenomenon, not photons. Quantum mechanics is an electron. It's a recognition of electron improbability or cause of displacement or change in the behavior of photons. So it's not a function of the quanta, it's a function of the quanta in the configuration of an electron. Because when they do this math out, so they do make this argument that all things contain this phenomenon. But they fool people because they make them think that if you do the two-slit experiment with flying pigs, that somehow you get the same results. And you don't. They're just talking about that you'd get the same tiny, tiny, minuscule change in the pig's landing on the on the wall, and it would be so infinitesimal that the lines essentially would be so tiny that you could never make a distinction, because the splatter of the pigs would way overwhelm the tiny, tiny quanta effect. So they're kind of deceiving people by making them think that the pig is going to move a whole like feet or yards to land at a different location on the target, when really all they're saying is that the energy in the pig is still quantized, and that there's still the quantum effect, and that there's this tiny irregularity of improbability in the landing of where the pig will land. But it's tiny. It's a tiny little line, and so tiny that we probably couldn't even measure the difference. So it is that process that has got them thinking, that this is a photon effect that just gets multiplied in these different these different creators of it. And so in the electron, they say, okay, the electron is already a problem, because the electron is already going to create finer lines. And then each scale you go bigger, the atom's going to create even smaller lines. And so as you get incrementally bigger in terms of the thing you're using as a projectile, your results will get finer and finer. The distinction in the movement, the overall difference in movement will get finer and finer. But yeah, they got it wrong. The source isn't the photon, the source is the electron. The electron is made of photons, and it's the configuration of those photons and the vibration of them in the electron that's creating the electron is the thing in states, and goes through state changes like a clock. It has state changes, and those state changes are what the photon is interacting with, and therefore changing its course depending on the state change of the electron. Whatever state the electron it happens to interact with is that electron changes, has a state, and it imposes a function onto the photon's direction based on its state. Alright, so I think this is a provable theory, and I think I'm gonna write this one up, and I think this is the explanation. So I will go indoors and do videotape and such. So is this still working? Yeah, I don't know how long these batteries will last, but I can always put new ones in. I've only got 8 minutes left, though. I'll have to see if I have something on here I can delete. Yeah. It's going to be a slow, long video. Well, I'll have to see what they use. I haven't used this camera in an awful long time, so I have to see what kind of quality it is anyway. Sound might be horrid. It's not very high quality video, but I think it'll be interesting video, so we'll go with it for that purpose. Really quite a lovely evening here. Probably doesn't look lovely from this camera's perspective, but it is lovely. And such. I hit the button. Okay, I'm back. Yay. I won't put the light on. We'll see what this camera does in terms of changing its, whatever, resolution. So anyway, this is a quantum mechanics from Yale University. I don't remember this professor's name, but it doesn't matter really. So this part he does talk about he's saying that under Newtonian mathematics, that this is, producing an electron would be done this way.
Not a big deal. So let's say this is the y direction. And you say, all right, I'll give you an electron with precisely known y coordinate and no uncertainty in y momentum by the following trick. I'll send a beam of electrons going in this direction in the x direction with some momentum p naught, and I put a hole in the middle, and the only guys escaping have to come out like this. So right outside, what do I have? I have an electron whose vertical momentum is exactly 0, because the beam had no vertical momentum, whose vertical position is equal to the width of the slit, is uncertain by the width of the slit, and I can make the width as narrow as I like. I can make my filter finer and finer and finer. So I'm able to give you electrons of perfectly well-defined position and perfectly well-defined momentum, namely 0. That's true in Newtonian mechanics, but it's not true in the quantum theory, because as you know, this
Okay, so I don't think this is even accurate to say this is true in Newtonian mechanics, because Newton was perfectly aware of this phenomenon of light with the glass thicknesses, and so, yeah, he didn't have knowledge of two slit experiments and trying to do, electron beams that were predictable, but I mean, he certainly knew of the fact that he knew what diffraction, and he knew light was affected by its transmission next to a surface. That interaction would affect light, that it would change its direction. He knew that. So what's being argued here is that somehow in Newtonian mechanics you can shoot a bunch of electrons through a tiny hole and one electron will come out straight, like there'll be a straight beam, and very predictable. And that's not Newtonian mechanics. I mean, it's not fair to Newton to say that's Newtonian mechanics. Like I said, certainly Newton didn't have the mathematics for all of diffraction and the whole quanta thing, but let's understand that that's not Newtonian. And because it was known of this fact that the photon could travel, like the smaller the aperture, the smaller the hole you make, the more likely the photon is to interact with the whole surface, the edge, the more likely it is to be affected by the atoms and molecule, the atoms and the electrons of the material that you're using as a screen or a filter, and you're likely to get some measure of a diffraction, some change in the direction of the photon. So clearly this is the cause of the wave function. The probability wave is being created by the aperture. It's being created not by the photon. It's being imposed on the photon by the mechanical structure. The experiment is creating the phenomenon, not the photon. The experiment isn't revealing what photons do. The experiment is revealing what structure does to photons. Clearly.
I mean, beam of electrons associated with the wave. The wave is going to fan out when it comes out, and we sort of know how much it's going to fan out. That's why I did that diffraction for you. It fans out by an angle theta, so that d sine theta is equal to lambda. That means light can come anywhere in this cone to your screen. That means the photons leaving, the electrons leaving, would have had a momentum in any of these directions. So the initial photon had a momentum p naught. The final one has a momentum of magnitude p naught, but whose direction is uncertain.
So he does like everybody else does. He keeps saying photon, then electron, then photon, then electron. So that's a common mistake. So, but the point is I think we get it, is that as this aperture, as this hole gets smaller to filter more precisely, so you're attempting to be more precise in your understanding of direction, the more precise you get in that direction, the more you lose your capacity. You lose the information in the sense that now you've created all these changes in potential direction. And that's really all that's happening here. And so it's completely, the two-slit experiment obliges one to have a non-aimed particle for the very precise reason that you're going to create this probability right there. You're going to create the uncertainty here. The uncertainty didn't exist here. The uncertainty exists here, and it's after the aperture. The aperture is creating the uncertainty. The size of the aperture is creating proportionally the amount of uncertainty, and the amount of uncertainty increases as you make the aperture smaller. And clearly that is because the smaller the aperture, the more likely whatever you're sending through it is to hit the edges. So if I have a ring of fire that a tiger's jumping through, and you know the ring's really big, then it's really easy for the tiger to get through without touching the fire. But if I make the ring really small, then the tiger might catch fire. And so with a small aperture, you're likely to have a photon that's now on fire, to use a metaphor. So anyway, yeah. So this to me is basically just a concession that the entire uncertainty is being created by the physical structure, and the physical structure is creating it because it's made of electrons, and electrons are what are imposing the uncertainty. It's the uncertainty of the position of the electron, the state of the electron, that the photon interacts with, that is affecting the direction. And whether it's an electron affecting an electron or an electron affecting a photon, the effect is going to be the same in terms of proportionality. Obviously electrons are bigger than photons, so now we get into that whole complexity that based on its size, the deviation will be less, but it'll also be less easy to see the deviation because the size of the entire experiment is larger. Yeah, it's one way to say it, I suppose. But anyway, it's just clear that the uncertainty is created by interaction with matter. That's what's creating it. The matter that has electrons associated with it. They could be free electrons in the sense that they're associated electrons. You know, most substances have electrons running across their surface that are shared electrons, so they're not bound. They're bound to the matter, but they're not bound to a specific atom, you could say. And those electrons could be the ones affecting the photon. Probably the likely ones affecting photons, interacting with a surface. So, yeah, I think that's slam dunk. I think we're done now, right? I mean, all this is just nonsense. Photons do not have any wave function. The wave function is completely and entirely forced on them by the experiment. If you were to use regular water waves as a metaphor with a boat on it or something, you could say the photon is being forced to move, okay, based on bumping into surfaces, and those surfaces being sticky versus not sticky, the opposite of sticky, whatever, sticks. So it runs into a bank, and the bank can either be something that has vines that are pulling it in or sticks that are pushing it away. And the vine or the sticks is decided by the state of an electron, and whatever state it's in, it's either a vine or a stick. Yeah, I thought this would have to be more than I thought it would. Maybe I won't bother with the comments. Well, maybe I'll save the comments for another video where this stroby thing doesn't happen as much. Yeah, maybe I'll do that. So this will be a test video. But I think we're done. And but nobody in the comments obviously didn't answer the question that why aiming would make a difference. How an aimed photon would know the difference between being aimed and not being aimed. A photon can't know the difference. It's just not possible. Hit the button, but it didn't work again. Cool.